So who is Ali in CNC Engineering, and what inspires you to get out of bed in the morning?
So I'm Ali Houston of CNC Machining. Started as a family-based business. My father started the business 30 odd years ago. So I've now taken over the reins, got majority shareholding. We're a contract manufacturing company, ranging from things for going up into space to agricultural bits to decorative parts for people, automotive space as well. So we serve pretty much all industries. The thing I really like about the business here is connecting with the staff and seeing their growth through the business. So that's something that really drives me to get out of bed every morning. And the other thing would be solving customers' problems. Customers come to us with a particular problem, whether it be a time frame one or whether it be a design element side of things. And so then we use the team to solve the solution and try and keep the customer as happy as possible.
Ali, could you go a bit deeper and give us some examples?
So our business is extremely difficult to be able to showcase exactly what we do because we make a very small component of a much bigger beast. So we've got a food labelling company that we do a whole lot of different components for, whereas we might make a piece on a end unit. And so if I'm to try and showcase and walk around the city and show people where our parts are, it's extremely difficult because quite often they're under the covers. And they're the important details, the things that make the point of difference to the customer. And it can range from the very smallest, tiniest bit that goes up into a satellite to a big massive casting that goes onto a range of gears to be able to drive a motor.
Many people don't realise that behind every structure, whether it be a building or a machine, there are engineered components to these structures, and why this behind the scenes work is critical to our economy.
Well, so there's a picture up there that we did for Wynyard Quarter, so the ASB building, and basically we had to make these stainless steel parts, an item like this. We had to make 9,999 of them. They had 36 different variations of different angles and bits and pieces. And it's to basically hold an aluminium pane on the outside of a window as a facade, as a sunshade as such. It's on a wire frame, and they've done it deliberately, and it was one of New Zealand's first green buildings of where it's done so that when the wind blows the rope, these panels all move around and basically it casts a shadow on the inside to symbolise leaves falling from a tree. So that's fun to be involved in and the complications that come along with them.
I find it fascinating how something so small and precise can play such a critical role in larger structures, and I can only imagine some of the design requests that come in must be just as fascinating.
It can be extremely fascinating depending on what the end result is. The other element that you get is you get a lot of design engineers that come in with this is the part that they want, but they don't understand that a particular tolerance will mean that the price will balloon out as a result. And then when you actually start asking some of these questions, they're like, oh no, it doesn't matter. I just auto-toleranced it and it really doesn't matter. So it's good to have the conversations with the customers so that we're not overdoing what we need to give the client at the end of the day. Nice.
Actually, that's just taken me back to when we were looking at your toolbox, your daily stand-up board, and you made a comment about overproduction versus underproduction. Yes. Could you please speak to that?
So in the CNC world, it takes quite a bit to actually set up a CNC machine. And so setup times can range from an hour to all day, depending on the complexity of the parts. And so when we first went down the lean side of things, the underproduction caused us more of a concern than the overproduction, because once a machine's set, the item might take 10-15 minutes to run. So if we ran 2 or 3 extras in case something went wrong to make sure that we got the end quantity for the customer, it's far better than having to reset the entire machine or machines, because some of our products can go through six or 7 different stages. And so we now make sure that we overproduce as opposed to under.
Ali, I'd love to expand a little bit more on your operational thinking and how you drive operational excellence and optimise productivity.
Productivity from my point of view is getting the parts off the machine faster. The sooner we get things off the machine, the sooner they go out the door. Obviously the money starts coming in, but it also then opens up better opportunities for us to utilise our equipment better than what we currently are. So what we try and do every time, and we've tried challenging the staff to this, but you have to get the culture embedded before it becomes second nature to the guys. But we observe what they're doing and then have a look and go and question them and go, could you get this a little bit faster if you moved this item over here, or if we moved a trolley beside you with the parts so you're not bending down to pick up from a health and safety point of view, all of those sorts of things. So we try and look at it in the finer detail as best we can, and again just trying to embed that culture so the guys are actually coming up with these solutions or even the problem to start with. Whereas when you first start lean, not everybody gets it and not everybody sees it, and some people think it's a bit of a waste of time, like, hey, I'm only saving a second of doing a particular motion, but that's a second for repetitive. So some of our jobs would be 500-600 items a day that the guys are doing, so 500 seconds that you're going to be saving every single day. Less energy required. So the big thing with lean that we try and get through is fix what bugs you and make things as simple as possible. Some people think that if you're making your job too simple, that you're being lazy, and we change the mindset from, we actually encourage lazy, because if you're being lazy, it means that you're getting things through faster.
You've mentioned the word lean a couple of times, and that's of course how we connected and partnered to support CNC engineering and further building that capability in lean and continuous improvement. But for those that perhaps haven't heard the word lean or lean manufacturing or lean thinking, how do you define it?
Lean for me is basically doing everything the simplest that you possibly can, and the fastest that you possibly can. And so a lot of the misconception with lean is everyone looks for these big massive game changers, whereas it doesn't have to be. If you look at the 2-second lean concept, if you save 2 seconds every day, that compiles over a year, and then you make significant changes. So over our particular journey, we've done some real simple little things, and then we've done some bigger things that have become from the simple thing. We make one little change and then go, oh hey, that can inspire this next item. So assuming we go around the tour, I can show you what we're doing with our tool changing. So when the mills go in and do a tool change, basically we've got everything there in one particular zone. Whereas previously they'd have to go backwards and forwards across the factory. And so one particular day we stood there and just watched how many times the guys did a tool change, how long that took, and then we moved some things around, redid that again, and saw the improvement that we had, to the stage that it saves about 2 to 3 hours a week now of wasted time, or downtime. Yeah.
You've mentioned the word culture a couple of times, and culture is foundational to a continuous improvement journey. I'd love to hear a little bit more about your journey in shaping culture within your organisation.
To be honest, it's extremely difficult. We've got a fairly good team here, but when we first started the journey, the original consultant, and it wasn't Lean Hub, the original consultant suggested that we should try and allow the entire team to drive the changes. And what we found is that didn't necessarily work. We actually needed somebody to do the original driving, keep everybody on task, still engage the entire team and inspire them and get all the different ideas. But unless you've got a particular focus until that culture's embedded, it falls off very quickly. It's a little bit like a committee. If you've got too many people around the table, nothing ever happens. And so from our point of view, we needed a couple of strong leaders to come in and drive it while the culture starts embedding. And we're still only early days at this particular point. So we've got probably half the staff that get it and half the staff that are wanting to do it. Yeah, it falls down at different times unless you're really driving it.
What do you think's different in the mindset of those that get it and those that don't?
Some of it is old-fashioned. We've always done it this way, and so therefore, why do I have to change? And some people actually like banging their heads against a brick wall. I can't fathom it myself. So it comes down to different people's responsibilities in the business. Some people think that it really doesn't matter and it doesn't impact on them, and others are constantly looking at it going, well, this actually bugs me and I want to fix it. And so that's what inspires them, because now they're empowered to be able to fix their own problems. as opposed to having to run to a manager or get approval for this or approval for that. And so we try and encourage them to do them. Obviously, big ticket items still has to come through the appropriate channels, because you can't just have an open checkbook for everybody, just go and do whatever they like.
I love your language there, fix what bugs me. It captures the heart of continuous improvement. And I know our facilitator, Colin, who you and the team are working with, is big on helping teams to uncover what bugs them, or looking for those TDIs, those tiny daily improvements, or what we called OFIs, opportunities for improvement. So how do you keep the momentum going with your team to continually look for those opportunities for improvement and fix what bugs them?
Currently, Colin. Basically, Colin's coming back in and double checking on the guys and making sure that we're following through with what we said we were. At the moment, in between times, it's me checking in with the guys and making sure that they're on top of their particular tasks. So a few of them have come back to me and said, hey, look, we're running out of time, we need some assistance to get this across the line. But yeah, just having that backstop of external source coming in, a new voice, somebody who's holding us to account. So that's quite powerful.
Colin's good at that. What are some of the improvements that you're working on?
So we're currently working on a single point clamping system for all of our mills. That particular swap out would save probably half an hour per setup, and we're doing 5 or 6 setups a day. So that's going to be a massive game changer for us. So that brings a massive productivity boost, and also takes away some of the frustration from the guys of every time that they have to change a job over. They'll either strip the entire table only for the next job to go back on with similar sort of setups. And so yeah, we've now gone through and made 20 of these what we're calling Mac lock systems.
I love that we're talking about not just equipment, but the human minds behind it, coming up with the ideas to improve the very tools that they work on. It's clear that developing people and building that capability is something that's really important to you.
Yeah, so we do a lot of on-job training. We generally try and take an apprentice that knows absolutely nothing about the industry and teach them all of our ways, as opposed to getting somebody in from industry who's already got a whole lot of bad habits. So Michael, who's effectively the main hand in the mill side, he came to us when he was 16, knew absolutely nothing, and now he's running some of the most complicated 5-axis machines in the world. So it's been great to see him from a young kid up until where he is now. And the development that he's gone through there. I've got my son coming through as an apprentice at the moment, so 3rd generation coming through. And just seeing from where he was a year ago to where he's now starting to click, and you can start seeing the excitement on their face when they learn a new skill. And then things like engaging with the Lean Hub and giving the rest of the staff the opportunity for personal development and growth. It keeps people interested, and it's just another way of making sure that you get a good culture and you keep your good staff. If you look after them, train them, inspire them, then they'll hang around forever.
With technology rapidly evolving, more automation, robotics, cobotics coming into the mix, what are you investing in to gain a competitive edge? And how is that influencing the type of talent that you need moving forward?
Well, in our terms, it would be looking at the automation side of things and the robotics and the unmanned machining. That will give us a competitive edge in industry and help offset some of the lower wage countries that bring in a whole lot of rubbish into the country. And so, yeah, and using the technology to our advantage, keeping our staff capable of doing more with less, in the sense that the machine's doing a lot more of the work, and so then the staff members more engaged in measuring items, running multiple machines, those sorts of things, doing a lot of the preparation work in advance so the machine doesn't stop. Just continuing to go down the automation space. And then that excites the younger generation coming through, because they get to play with robots and 3D printers and all the latest technologies, and that's what really sparks them and encourages them to come along.
Nice. Where do you see the industry going, and what does the future of work in engineering look like?
It's a bit difficult. Engineering as a whole has sort of shrunk over a long period of time through different government policies and procedures. Where New Zealand sort of fits the marketplace would be in the prototyping and the niche side of things, the number 8 wire solutions as such. You look at the likes of Rocket Lab and how quickly they were able to get to market. whereas in other countries you wouldn't be able to get into that space. In our particular industry or our area in the market, we're into the small to medium sort of run sizes, and that still is growing in New Zealand. But if you look at the massive quantities and that sort of stuff, that's all offshore, and so that's really impacted on the industry. Some of the big players have come and gone as a result of it. Some of the bean counters look at importing as opposed to making it here in New Zealand. So it's a little bit difficult, and the only way that we're able to survive and thrive is to go down that automation space, so that we can do things at a lower labour rate and still be profitable and still high quality.
Yeah, we can sometimes import or downgrade to a cheaper part, but will that choice deliver long-term reliability? Will it drive the most value out of our asset? Focusing solely on immediate cost can sometimes lead to short-term compromises or short-term thinking.
Very short-term thinking in a lot of cases, yeah.
So how do we change that?
I think the government needs to mandate a certain amount of production must be done in New Zealand, or a certain amount of whatever your end product is must be manufactured in New Zealand or assembled in New Zealand, or some way of making sure that it's still here. The government actually purchasing New Zealand made as opposed to going out and purchasing from all over the rest of the world. Now the defence investment that the government's got, I'm hoping and expecting a lot of that to remain in New Zealand. In the past that would have all been shipped off overseas, so the government has a massive amount of investment and then sends it offshore, which again I think they need to mandate a certain amount, whether it be 25%, 50%, whatever it might be, must be manufactured in New Zealand.
It really opens up this wider conversation around talent shortfall, and there's some great work going on with the likes of AMA, Advancing Manufacturing Aotearoa here in New Zealand, to shift the perception of engineering and manufacturing as career pathways. What are your thoughts? How do we encourage more apprenticeships and grow that talent pipeline into the industry?
Better education. You don't know what you don't know, and so a lot of the young kids have no idea what CNCs are, or if they think of engineering, they think of dirty and horrible, sweaty sort of areas, or they think of something extremely old and run down, or a process worker who's just standing on a line. And so we've engaged with some of the schools in recent times, and a lot of the misperception is from the parents. So the parents don't want the kids to get into engineering because that's all that they thought engineering was. They don't understand all the cool things that you can design, all the differences that you can make in the world. To be able to say that you do stuff that goes up in space is just absolutely phenomenal. So that having a young kid to come in and be involved in that. We've got a bit of a generational issue at the moment with the young kids of where they don't actually want to work, or if they come in, they try and dictate the working environment, or they want to be the CEO straight away. So there's a little bit of that needs to be in, but I think more into the schools, try and get CNCs or the concept of CNCs into intermediate, into high schools. But then that comes back to that investment that we were talking before. So schools obviously don't have huge budgets, so for them to get involved in CNCs is a little bit difficult. They're starting to get involved in laser cutting and 3D printing, so that's at least starting to encourage that particular space. But just more education around the kids being able to do things like open days and actually show them what they could do beyond school, because not everybody wants to go to university. Some people like getting their hands dirty and getting involved and being able to be making things. So.
It's that visibility, like what you said earlier, you don't know what you don't know.
Yep. Engineering can take people around the world, and people can make significant money in engineering. So it's not a dead-end job, and engineering's pretty cool. It's a lot of fun, and you get to play with some really cool toys and make some really cool stuff. So the young kids out there, it is a good career path.
Nice. Well, I think that's a perfect sentence to wrap it up. Thanks so much, Ali.